Today we're going to look at inverse proportion. Now, to understand inverse proportion, we're going to consider a brick wall. So let's consider the scenario where you have one bricklayer and he's got to build a wall. So let's let n be the number of bricklayers and t be the time that it takes to build the brick wall. And if you've got one builder, it might take him, say, 10 hours to build the wall. Let's increase the number. Let's go to 4 bricklayers. We've got 4 bricklayers. The time to build that wall significantly decreases because we've still got to build the same size wall. So let's say it's 5 hours. Let's suppose it's actually halved in time. And as we increase the number of builders, the time it takes to build the wall actually decreases. When you've got a relationship where one of the variables or the independent variable increases and the dependent variable decreases, that's called an inverse proportional, inversely varies, okay? It's a relationship. Now, when I graph this, if you're familiar with the reciprocal function or the hyperbola function, you will recognize that graph. So I'm just going to have n along the bottom, because that's the number of builders, that's our independent variable, and the time taken will decrease. And the graph actually looks like this. As one increases, the other decreases as it comes down. Now, this relationship, you'll notice, never ever, if this graph keeps going and going, it will never ever reach 0. That's because it doesn't matter how many builders you have, you still have a brick wall to build. So it's not ever going to take 0 time to build the wall. It might be a very, very small time, but it always takes a particular amount of time to build this brick wall. So we call this line here an asymptote. And it might be that you need to watch the videos about hyperbolas to understand this kind of graph in a bit more detail. What I'm going to do is I'm going to show you how we identify an inverse proportion relationship. Okay, so I'm just going to write this relationship down for this particular scenario. If t is inversely proportional to n, we say that t, and to show that it's inversely proportional, we need to do 1 over n. Now, anyone who's seen this before, this is the inverse, this is a proportional sign. To show it's inversely proportional, this is obviously why we've got the variable on the denominator, because it's inversely proportional. Now, what we do then is we say that in order for these two to be equal, there must be a constant. So that constant, we use the letter k to describe that constant, and we're going to find out with this relationship what the constant k is. Alright, so let's apply it to this problem here. Now, the information I can give you is that t is inversely proportional to the square root of n. What we're going to do is use some of these values to find out what that constant k is. So let's just use the first variable we've got. So when t is 10, n is 1. So we've got k over the square root of 1. Square root of 1 is 1, so we've got 10 equals k. So our constant is equal to 10. We can now therefore say that t is equal to 10 over the square root of n. And that's pretty much all you need to know about inverse proportion relationships.